Hello and welcome to yet another episode where we shall be looking at the suggested proposed memorandum for mathematics paper 2, virtual for November 2024. All right, so paper is 3 hours, 150. The instructions, we have 11 questions. We're going to use a special answer book. Answers only will not be awarded marks, so we shall break down that calculator. If necessary, we must round off our answers to 2 decimal places unless stated otherwise. Okay. All right. Then question number 1, which is always the statistics, are telling us that at the beginning of a season, the coach of the junior boys rugby team recorded the weight in kilograms of the 15 players, okay, in his team, and then the number of push-ups that each one was able to do in just 1 minute. Okay. The data is represented in the table and then the scatter plot below. The least square regression has been drawn for us. All right, so we can see that the weight is in kilograms, good. And the number of push-ups will be the Y. We have all those details. Then 1.1, they're asking us to determine the equation of the least square regression line for the data. So we know that that equation is given as Y is equal to A plus BX. Some people choose to write it as A plus capital B, X. It does not matter. All we need to do is use our calculators and look for the mode of the two var, okay, and then punch in these values. So having done that, the answers or the values that I obtained for A was, let me put it aside, in the answer book. So we're saying that A is 39,456, which I'll maybe round off to 46. Okay. And then my B is a negative 0.59 if I round it off to 2 decimals. Okay, then this is number of push, okay. So which means our equation will be 39,46 minus 0.59x. So a mark for A, a mark for B, and then a mark for the equation. Then 1.2, they want us to write the correlation coefficient. So that is the value of R. So from my calculator, when I punch that, I'm getting negative 0.799 something, which I round off to negative 0.80, or just negative 0.8, okay? Then 1.3, they're telling us that the coach uses the least square regression line to set the target for the minimum number of push-ups by each team member according to their weight. Can we predict the number of push-ups that the member of the team who weighs 29 kilograms should do to meet the target? So we've been given the weight, and the weight is representing the X. So we must look for the Y using the regression equation. So Y is going to be 39,46 minus 0.59. We are multiplying this by 29. Okay. So when I punch that into my calculator, that's 39,46 minus 0.59 times 29. That is giving me 22,35. We can just round off this. Maybe someone must do 23 push-ups. Okay, since push-ups are just a countable quantity and not necessarily measurable. All right, then 1.4, they want us to get the mean number of push-ups for the given data. Mean number of push-ups, which means we're looking at the Y values, okay? So we know that for us to get the mean, we shall just add that, and then the answer we get, we divide it by 15, or you can just directly punch that into your calculator. So I'll say the mean for the push-ups, which is X bar, will be the summation, which is 537 divided by 15. This is giving me 35 8. If you round that off, you'll get to 36 push-ups. Okay. Then 1.5. The players trained hard during the session. At the end of the session, the coach reported that each player was able to do 5 extra push-ups. Okay, each player, in other words, all the players had something to be added, which was the same per minute than they did at the beginning of the session. How does the increase in the number of push-ups influence the standard deviation for 1 mark? So in normal cases, for as long as there's an addition or subtraction that is uniformly done across the data pieces, it does not affect the standard deviation, okay? It will only affect the mean. So we can say that SD is not affected. Okay, we can alternatively say that SD remains the same. It remains the same. So that is for standard deviation. Had it been that it was the mean, then the mean was going to increase by 5. All right, then 1.6. At the beginning of the season, the coach used the least square regression line as a minimum target for a player to aim for. Okay, in other words, there was a target that was set that for every player that is what you must reach. Determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. Okay. So what we're going to do in this case, Okay, so initially in 1.4, we saw that the mean or the average that we're looking at was a 35,8 push-ups, okay? But then from our regression line, if we are to look at the y-intercept of this graph, remember from our equation, we found it to be a 39, or something, okay? So y-intercept, okay, we're saying the y-intercept is a 39,46. But then currently the average is a 35,8. What is the question asking for? Question is asking to determine the maximum possible increase in the number of push-ups. So for us to get a target of 39,46, how many extras can we add? So I'm just going to say 39,46 minus 35,8. Okay, 39,46 minus 35,8. That gives me around about 3,66, which is approximately 4 push-ups that must be increased, or that will be the increase for them to get the target from the mean or the average. All right, so that is what I would have done with question number 1. Okay. Then question number 2, we are given the frequency graph, the cumulative frequency graph, the ogive, and then we need to answer questions. Okay, so number 1, they want us to estimate the mean. So remember, we are estimating. So our answers might be slightly different by just decimals or just a few numbers. So for us to get the median, what we need to do, there is that formula that we normally use to say that Q2 will be a half of n plus 1. That is, if we are looking for the position. Okay. Then if we do the substitution, we know that our n is 60, because the question told us that we're dealing with 60 employees, okay, that travel to work each morning. So that's going to be a half of 61, which gives me 30,5. So that is just the position. But now the Q2 value from the ogive will be, let me see, 30,5 is round about that point. When I drop it down, I'm getting something like within this line. So if that is 10, which means each block is 2, so that is going to be like 66 minutes. Okay. There are people that might use a half of 60, which is a 30, and the 30 will give you something like a 65. Okay, so I'll go with 66. 65, they might give you also. Then estimate the lower quartile, that is the Q1. So with the Q1, we know that it's going to be a quarter of n plus 1. So that will be a quarter of 60 plus 1, which is 61. And that gives me 15,25 as the position, which means the Q1 value, if it is 15,25, the answer I'm getting is a 44. 15 comma something. Yeah, it's somewhere there. Because I'm taking it from here, just slightly above 15, or just within the line of 15. So we're getting 44. If you're using just a quarter of 60, which will be exactly on 15, that might give you something like a 43, okay? And then 2.3. 2.3, they want us to get the interquartile range. So we know that interquartile range is given as the Q3. We subtract the Q1. We already have the Q1. What is shorting is the Q3. Let's get the position of Q3, which is 3 over 4 into n plus 1, which is 3 over 4 of 61. That gives me 47,75, okay? So from our graph, 40, did I say 47 or 45? 45,75, yes. So 45,75 is just more like close to 46. And we can have that value at this point. Okay, it can be between 80. It's 8 what? Remember, it's a 45, not yet a 46, so slightly below, which is somewhere there like 80. Is it 86, 85? My graph is not. Okay, so if I look at 45,75, which is more like 46, round about that value, I'm getting 84 as my Q3, okay? So which means my Q3 is going to be 84. Then when I get the IQR, answering the question now, it's going to be 84 minus a 44, which gives me a 40. 84 minus 44, it's giving me a 40. So that is how I would have gone about with that question, 2.3. And then 2.4. 2.4, they're asking us, or they're telling us that the minimum and the maximum times taken for an employee to travel to work are 5 and 120 minutes, respectively. So on a scaled line in the answer book, can we draw a box and whisker diagram for the data? Okay. So one thing we know about the box and whisker, it represents the 5-number summary, whereby we shall have the minimum, the Q1, the Q2, the Q3, as well as the maximum. So our minimum, they told us is 5. So that will be our 5. Our maximum is going to be 120. We say that the Q1 is 44. So 44 is just slightly before that middle line. And then our Q2, we got it as 66. So slightly after that line. And then the Q3, we're seeing 84, which is slightly before that line of 85. And then just draw your box with your ruler. Okay, connect that. Connect this to the end, and then connect this to the start. So that becomes our box and whisker plot, something like that. Okay, so then 2.5, they're telling us that the company manager decided that all employees who travel for an hour or more will be allowed to work from home for part of the day. What percentage of employees will be allowed to work from home for part of the day? Okay, so when they talk about an hour, so that's basically 60 minutes. So we want to see how many employees are using more than an hour to get to work. Okay. So 60 minutes, we have this line. Follow that line of 60 up until it meets the ogive, and then we take the reading from this side. So that should be around about 26, okay, around about 26. So we know that at 60, we have the cumulative frequency of 26. So the employees that traveled more than 60 minutes will be 60 minus 26, because we remember we're looking at a total of 60 employees. So 60 minus 26, that is a 30 what? It is a 34. Then 2.6, employees will work 8 hours in a normal working day. The manager decided on the following rule for time to work from home. Okay. So an employee is allowed to work half an hour from home for each interval of 20 minutes or part thereof above an hour taken to travel. So for people that are using more than 60 minutes to travel, okay, from 60 upwards, they will be given half an hour to work from home for every interval, which means that from 60 to 80, you'll have half an hour. From 80 to 100, that's half an hour. From 100 to 120, that's also another half an hour. Then the question is asking us that on a certain day, there's an employee that takes 110 minutes to travel to work. Calculate the number of minutes that this employee will be allowed to work from home on that particular day. So 110 falls within this category of 100 to 120, okay? The section of thereof, part thereof, simply means even if it's not a full 20 minutes, but just part of the 20 minutes, you still qualify for the half an hour. So how many hours or how many minutes? So we're going to say we have half an hour, which is like 30 minutes. That's another 30, and then that is also going to be another 30. So we can say we have 30 times 3, which gives us 90 minutes. Okay, so that is question number 2. Question 3. Question 3. Did we answer question 2.5? Something is not making sure. 2.5, we're saying what percentage are allowed to work from home. We just got the number. Okay, so it's going to be 34 over 60 times 100, which is 56.67%. Okay, let's move on to question 3. I'm telling us that on the diagram below, ACD has vertices A, we have D, C, where A is the point in the second quadrant. And then they're telling us that B is -1 and K, which lies on the side of DC. 3.1, they want us to get the gradient of CD or DC. Let me put it aside. So we know that gradient is change in Y over the change in X. So I'll say 0 minus -9 over -9 minus 3. That will give me 9 over -12, which is going to be -3 over 4. So that is the gradient of DC. Then 3.2, I want us to get the equation of DC. So I can use point C and say that Y minus 0 is equal to -3 over 4 into X minus -9. So Y is going to be -3 over 4X. That's going to be a plus, and then now a minus 27 over 4. That's 3.2. And then 3.3, they want us to show that K is -6. So since we already have the equation, all we can do is just do the substitution, okay? Where there is X, we put a -1 into this equation, and then we solve. So which means Y is going to be -3 over 4 times -1 minus 27 over 4. So that gives us 3 over 4 minus 27 over 4 That's going to be negative 24 over 4, which is a negative 6. All right, then 3.4. Can we calculate the length DC? So with DC, we have to use the distance formula. Okay, so that will be x minus x1 squared, and then y minus y1 squared. If you do your substitutions, that's going to be negative 9 minus 3 squared plus 0 minus minus 9 squared. This must be under the root sign. So when I punch that into my calculator, okay, negative 9, and then that is a 12. I'm ending up with 15 units. Okay, so that is 15 units. All right, then 3.5. They want us to get the ratio of dB over dC. So what we're going to do, since they're talking about the ratio, dB simply represents the length, okay? But we know that that's a -1, this is a -6. So let's use, again, the distance formula to find the distance dB, okay? So dB is going to be the square root. Okay, from the distance formula, we shall have 3 minus minus 1 squared plus -9 minus minus 6 squared. So when I punch that into the calculator, that's going to give me a 5, okay? And then for me to represent the units, going to be 5 units over 15 units, which is just 1 over 3. So that becomes the ratio. Then 3.6. M is a point on AD such that AC is parallel to MB. Calculate the ratio of area of MBD over the area of ACD. Now, if I'm to just imagine of a line, something like that, if that is our imaginary line, and maybe this is our point M, okay? So for us to get the area, okay, let me just put it this side. Okay, so we're saying this is our line. We say this is a 5. All of that is 15. This is a point M. So that these lines are parallel. So if we have that, then we shall have similar triangles, okay? So if we have similar triangles, I can create a 90 or a perpendicular height. So if let's say I have this as my perpendicular height. So for me to get the area of MDB, it's going to be a half multiplied by this height that I created, multiplied by the base, which is BD. Then if I look for the area of the big triangle, which is ACD, which means I'm going to use the same height for this case, okay? Which is a half times the entire distance, which is our base, which is DC, multiplied by the same height. So if I'm to compare the two, which means I'll have a half times DC times H. So a half and a half will cancel, the H and the H will cancel, which means I'll be left with just a BD over a DC. So my BD is 5, that is 15, which means the ratio of the area will also be in that format, 1 over 3. All right, so that is 3.6. Then 3.7, they're telling us that if it is further given that AD or the gradient of AD is -4, Okay, so here we have the gradient as -4. Then the distance or the length of AD is 612. Okay, AD 612. What do they want us to do? We need to find the coordinates of A. Okay. So our point of M is not going to be of relevance, okay? Because all we need to know is we need A, which I'm just going to name as X and Y. We already have the coordinates of D, which are 3 and -9. Okay, so our gradient is -4, and then our distance is square root of, they said 6 what? So 612. Okay. How many marks is it? It's 6 marks. Okay, so I'm going to use the gradient formula. And then I'm also going to use the distance formula in both scenarios, and then I'll solve the equations simultaneously. So let's start with the gradient formula. So we know that the gradient of AD is going to be the change in Y over change in X. So that's going to be Y minus -9 over X minus 3. This must give us -4. You can cross multiply. So Y plus 9 is going to be -4 into X minus 3. We open that up, -4X. That's going to be a plus 12. Let's move the 9 that side. So -4X plus a 3. Let me call that equation number 1. Then I look at the distance formula and say that my AD is going to be the square root of X minus X1 squared, and then Y minus Y1 squared. So root 612 is equal to the square root of X minus 3 squared plus Y minus -9 squared. Now, since we have root signs on either sides, I can square both sides. Okay, so I have 612 is equal to, that's going to be X squared. I'm opening the brackets, 6X plus 9. That's going to be Y squared. Remember, this is now a plus. So plus 18Y, and then plus 81. But remember our Y, okay, if this is equation number 2, let's substitute this Y into this equation. So 612 is equal to X squared minus 6X. This and this is going to give us a 90. We have -4X plus 3. We're squaring that. Plus 18 to -4X plus 3. We said plus a 19. Let's move everything to one side as we simplify. So X squared minus 6X, opening this up, I'll have 16X squared. This is 12 times 2. I'm going to get 24X. Okay. After getting the 24X, I'll have a plus 9. Open that up. I have -72X. 18 and 3 is going to give me a positive 54. And then plus 90. And then I'm subtracting 612. Should give me a 0. So I know that X squared and that, I'll get 17X squared. Minus 6 minus that is minus 30. And then if I subtract that, I have -102X. Okay. Then the 9, the 54, the 90, and the 612, I'm just getting a positive 459 is equal to 0. Then all I'll do is divide through by 17, okay? That will give me X squared minus 6X minus 27 is equal to 0. I'll factor this out. I will use the quadratic formula. So X and X, let me make this a 9, a 3. I'll make this a negative and a positive, okay? So which means our X can be -3 or X is going to be a 9. But since the A, okay, is in the second quadrant, which means the X is going to be -3, okay? So which means the Y values in this case, we substitute into that equation was -4X plus 3. So -4 and then -3 plus 3. That is going to give us what? Because this is going to be 12 and then 3, which is 15, which means the coordinates of A are -3 and then 15. So that is how this question was meant to be approached. All right, that is question number 3. Question 4. In the diagram, M is 1, 3, is the center of the circle. Okay. And then the circle cuts the x-axis at N, we can see that. And then ST is given as a tangent to the circle, with P being that R is gain 1, where D is greater than 0, which means it's positive. L lies on the circle. O and V are x-intercepts. O and V are x-intercepts. PL and RL, okay, those ones are drawn, okay. And they want us to get the coordinates of L. The quickest approach to use in this case was the midpoint method, because we know that this M is the center, which is the midpoint of this and this. So we know that if we have x1 and x2 divided by 2, and then we have y1 plus y2 divided by 2, this is the midpoint formula. So if I get x, okay, we're saying L is x and y. So x plus the 3 divided by 2, I should get my x value, which is a 1. Cross multiply, x plus 3 should be a 2, which means x is a -1. I'll do the same with the y and say that if I have y plus 9 divided by 2, I must get a 3. Cross multiply, y plus 9 is going to give me a 6, which means y is -3. So coordinates of L are -1 and -3. So on the, it's in the fourth quadrant there. Sorry, the third quadrant. Then 4.2, they want us to get the equation of the tangent, ST. So for us to get the equation of this tangent, we know the coordinates of M, we know the coordinates of P. And we know that the tangent and the radius, or tangent and diameter, will be perpendicular, okay, which means that ST is perpendicular to PL. This is tan radius, or tan perpendicular to diameter. So if we get the gradient of PM, okay, we say change in y over change in x. So that's going to be 9 minus 3 over 3 minus 1. So 6 over 2, which gives us a 3. Then which means that the gradient of the tangent, remember for perpendicular lines, M1 times M2 must give us -1. Now we already have our M1 as a 3, which means M2 is going to be -1/3. So this is the gradient of the tangent. So the equation, I'm going to say using P, okay, using P, y minus 9 is equal to -1/3 into x minus 3. Let's open that up. Y minus 9 is -1/3 plus 1. When I move this 9 to that side, which means it's -1/3 x plus 10. So that is the equation of the tangent that I'm getting for 4.2. All right, then 4.3, can we show that this equation of the circle is given as this? So we have the equation, we just have to move towards that. So we have the center coordinates, which is beautiful. What is shorting is just the radius. So let's calculate the radius. So PM, the distance PM, this is 4.3. Okay, so PM, remember, we have 1 and 3. Then we have 3 and 9. All right, so I would say R squared is going to be 3 minus 1 squared plus 9 minus 3 squared. So that is going to be 2 squared, which is a 4, plus 6 squared, which is a 36, which gives me 40. So my R squared is a 40. Then we know that for equation of a line, so a circle, is given as x minus that, y minus that is equal to r squared, which is x minus 1 squared, and then y minus 3 squared. Our r squared is a 14. If you found the square root there, you can square it again and get back that. Let's open this up. That's going to be x squared minus 2x plus 1. Open this up. It's y squared minus 6y plus 9. Let's move the 40 that side. Minus 40 is 0. So we have x squared plus y squared. We have the minus 2x. Why am I saying 26? We said 2x. Okay. Minus 6y. This and this is a 10. Minus 40 plus 10 is giving me minus 30 is equal to 0. All right, so that is how we would have proved this equation. Then 4.4, can we show that D is a 7? Where is D? D is on point R, okay? So what we can do, we can use the equation of a circle since D is lying on the circle, okay? Where there is Y, let's put 1, and then let's look for X. Would that be the easiest and quickest? I guess so. That is one approach, if we can use the equation of the circle. Alternatively, we can, we know that this is a diameter, which means the angle here will be 90. We have these coordinates, so we can try the gradient. Gradient of this times gradient of that must give us -1. Let's see if we shall get the same answers. So substitute y as a 1. So we shall have x squared plus 1 squared minus 2x minus 6 and 1 minus 30 is a 0. Collect the like terms, x squared minus 2x. This is going to be minus 36 plus 1, which is minus 35 is 0. Vector this out. That is x and a 7, x and a 5. Make this a minus and a plus. So x is either 7 or x is going to be a minus 5. But we're looking at D on the positive axis. Therefore, D is going to be a 7. For people that were using the gradient, how are we going to go about that? Let's use something else here. Okay. So we're saying 1 minus minus 3 over D minus minus 1 multiplied by 9 minus 1 over 3 minus D should give us -1. So that will be 4 over D minus 1. You're multiplying it by 8 over 3 minus D should give us a -1. So this is going to give us also a quadratic, which must take us around about that. But substitution was going to be the quickest. Okay. It was going to be the quickest. All right. Then 4.5. 4.5, they want us to calculate the size of L for 5 marks. All right. So what I'm going to do here. Okay. What I'm going to do. I need to know, 1, the gradient of this line, which we got as a 3. Okay, that is the gradient. Then if I can get this angle of inclination, okay, I already know that this is my 90. I need to find this angle here, P. And how am I going to do that? I need to locate the angle of inclination of this line also. So I'm just going to extend this and call this maybe a point Q. Let me find this inclination angle. Okay, then I focus on P or Q. Will that make sense? So that I know that this angle is going to be a sum of this angle and this angle here from this triangle that I'm calling pink. Okay, let's start with triangle pink. All right, so let me call this No, I don't need to call it theta or what. Let me just call it POX. Yeah, that's fair. That's better. Okay, so I'm going to say that M is equal to the tan of POX. But our M is a 3, which means 3 is equal to the tan of POX. Then for us to get the POX, is going to be the arctan of 3. So arctan of 3 is giving me 71.57 degrees. Okay. So we're saying this is a 71.57. Then do we know the gradient of this line? We can find it. Ne? We can find it. So saying gradient of PQ, remember the coordinates up there were 3 and 9, okay? Let me just put them here. 3 and 9, and then we have 7 and 1. Let's do the magic. So it's going to be 9 minus 1 over 3 minus 7. That's 8 over negative 4, which gives us negative 2. Which means PQX, same story. So PQX is going to be the arctan of negative 2. Okay, punching that, I'll get a negative answer, and then I have to plus the 180. I can focus on the positive and then subtract the 180 or subtract from 180. So arctan of negative 2 is giving me negative 63 plus that. When I add the 180, I'm getting 116.57. Okay, so 116.57. Then OPR, okay, saying OPR is going to be 116.57 minus 71.57. Okay, 116.57 minus 71.57, which gives me a 45. Okay, so if this is a 45, but we're saying that PRL, okay, PRL is a 90, that is angle in a semicircle, which means that L is also going to be 45 angles in a triangle, because 45, 90, then this must also be a 45. All right, that is how I would have approached 4.5. Then TR is a tangent. This one is now crowded. Let's use this side. They're telling us that TR is a tangent. Okay, let's just sketch it that way. Okay. So if TR is a tangent at R, can we prove that PT is perpendicular to RT? Can we prove that PT is perpendicular to RT? In other words, we must prove that there is a 90-degree there. Okay. Now, what we just proved was that this is a 45. Okay. So if that is a 45, this is a tangent. So what we're going to use will be the theorems, okay, because we're having a circle there, so we can use the circle theorems. Let's read the question again. Can we prove that the sides are perpendicular? So what I'm going to do, I'm going to say this angle is a 45 because this and this will be equal, tan chord. Okay, so I'm saying TPR is 45 degrees. That is tan chord. Then I can also now, since I have this as a 45, I can declare TRP as a 45 also. I can either give the tangents from a common point are equal, okay, or we can still use our tan chord because it still holds in this case. Then if that is true, if that's a 45 and that is also 45, then we can say that angle T or PTR is going to be 90 because those are angles in a triangle. And since it's a 90, therefore PT is perpendicular to TR. All right, so that is how we would have gone about with question number 4. Question number 5, which is trig. They are telling us that in the diagram, okay, there's a line OP, which is given with P being -3 and -4. Then KOP is A without using a calculator. It's in bold. Must find the value of cos A. So step number 1, complete this triangle. Okay, let's use red. Let's complete it. And let's have a 90 there. Now this is the -3. This is the -4 because it's X and Y. Then we need to find OP. So OP is going to be the square root of -3 squared plus -4 squared. Reason, we're using the Pythagoras. Okay, so which means our OP is going to be a 5. Now remember, when you're finding the hypotenuse, we can never have a negative. It's always a positive value. So if our triangle is finished, I think that's where we're going to get the first mark for completing the triangle. Then now to get the cos, we know that cos from our trig ratios is adjacent over hypotenuse. So if the all of this is A, it's as good as just focusing on that inside part as A. Okay, so adjacent is -3, hypotenuse is a 5. So it's -3 over 5. All right, then 5.1.2, they want the cos of 2A. So this is a double angle. And then from our formula page, we know that the cos 2A can be the same as 2 cos squared A minus 1. And then we just have to substitute this. So that will be 2. We got the cos as -3 over 5. We square that, and then we subtract 1. So 3 squared is going to be 9 over 25. 9 times 2 is going to be 18 over 25 minus 1, which is giving me -7 over 25. Okay, so that is that. Now, even if you use a different format of cos 2A, we must still arrive at the same answer, which is -7 over 25. Then 5.1.3, they want us to calculate this if it's further given that sine B is this. All right, so what we're seeing is that we have something extra now. Sine B is 4 over 5, but B is between 90 and 360. So from this point, because this is our 90, 180, 270, and then 360. So what's going to happen is this ratio is positive. So in these 3 quadrants, we know that sine is positive just in the second. So which means I need to draw something like that. Why don't I use a different color? Okay, just draw something for B in this sort of format. Makes a 90, then the whole of that is a B. But they told us sine. We know that sine is the opposite, which is 4 over the hypotenuse, which is 5. Now, if you apply your theorem of Pythagoras, we know that this adjacent is still going to be a 3, which is on the negative side, which is the same as a -3. So both triangles are using a -3. Okay, so let's break this down using the compound angles. So sine A, that is going to be the same as sine A cos of B minus sine B cos of A. Yeah, whichever format it is, but it is like that. Then sine of A, we said it's going to be opposite over hypotenuse. So -4 over 5 times the cos of B is adjacent over hypotenuse, which is -3 over 5. Now we are subtracting the sine of B. Sine of B, we have it as a 4 over 5 already, no? Which is 4 over 5. And then the cos of A, we calculated it as -3 over 5. So simplify that, that's 12 over 25. Negative, I'm getting a plus now, 12 also over 25. So 12 over 25, 12 over 25, we shall end up with 24 over 25. So that is what I'm getting for 5.1.3. Then 5.2, which is a bit separate from our diagrams up there, they're telling us that if cos alpha is a p, can we express the following expression in terms of p? Now, there's something that we need to see or to understand with this expression, that there's something funny, okay? We have cos sine, okay? This is more like the identity of the double angle of sine, okay? Let me say we have the sine 2 alpha. No, let me not use alpha because I'll end up confusing people. I'll say sine 2a. It's given as 2 sine a cos a. Okay, so I'm going to take this entire bracket to represent my a. So I have my cos and then my sine. What am I shorting with? I'm shorting with this 2. So divide both sides by 2, eliminate that 2, which means that this sine a cos a is equivalent to a half sine of 2a, okay? So I'm replacing this with a half sine 2, but my a is alpha over 2 minus a 45. I'm dividing this by 2. Okay, so a half divided by 2, I'm gonna end up with a quarter, okay? This is the sine of, let me open this up. So alpha over 2 times 2, I'll be left with just alpha, 2 and 45, that's 90. Let's factor out the negative sign. So sine negative, that's gonna be 90 minus alpha. Take the negative that side. We shall have the sine of 90 minus alpha. So from our reduction, we know that sine of 90 minus alpha will give us a cos of alpha. So this is gonna be negative a quarter cos of alpha, but the cos of alpha is a p, which means our final answer should be negative a quarter p. So that is question number 5. Question number 6. Question number 6. Given the identity, cos of x minus y is equal to cos x cos y plus sin x sin y. Use the compound angle identity given above to derive the formula for that. So we can use the 90 sort of approach, but we can also use something extra, okay? So I'm gonna replace, okay, positive y with the negative y, okay, into this expression. Okay, that's gonna be my first step. Let y be equal to negative y. So that then I'm gonna have cos of x minus, now with the minus y, is equal to the cos of x and then the cos of negative y, okay, plus I have the sine of x and then the sine of negative y. I know that this negative and negative will give me the positive, so I'll end up with the cos of x plus y is equal to, that's gonna be cos of x. We know that the cos of a negative angle is the same as the cos of a positive angle. So that is a cos y. Then the sine of a negative angle, we have to take the sine out. So that's gonna be like negative sine y, okay? Negative or positive, we'll get a negative sine x and then sine y. So I have proved, or I have derived just from that. So some people would choose to use the 90 minus 90 plus, well and good, okay? I'm using this. So that is how I would have gone about that. And then hence, or otherwise, hence. So hence simply means that with what we have, with this sort of identity, remember we have the identity of cos x plus y is given as this. So where there is x plus y, cos of x plus y, we can replace it with all of that. Either way, okay? So we need to simplify that. We need to simplify that. So let's see what we have this side. That is 6.1.2. Let me write the question out. We have the cos of 90 minus x. Okay, we're multiplying by the cos y plus sine of negative y. Okay, times the cos of 180 plus x over cos x. Okay, that is cos x, and then cos of 360 plus y, and then plus sine of 360 minus x, and then sine of y. All right, so they're telling us this is equal to the tan of x plus y. All right, let me start from the left-hand side, okay? Left-hand side. So 90 minus will give me sine of x using the reductions because it's a compound angle. Then that's cos y. We can't do anything about that. Then the negative sine of an angle, it will be negative sine cos of 180 plus, this is quadrant 3, where cos is negative. Okay, so negative cos of x. This is sine y. Okay, over, that's cos x, 360 plus, that is in quadrant 1, where the cos is positive, the cos y. 360 minus, that is in the fourth quadrant, where the sine is negative, and then sine y. All right, let me simplify that. So that's going to be sine x cos y, that and that will have a plus. Sine y cos x over, that's going to give me cos x cos y minus. Is that a minus or it's a plus? We say this is a positive. 360 minus the die. Let me just go back and see. 360 plus. This is quadrant 1, which is cos y. 360 minus, that's going to be negative. Am I on the right track? Because this is sine x. Okay. Right, it's fine. Let's move on. So that is going to be sine x and then sine y. All right. Then let's, because now these are compound angles, let's move backwards. So this is sine cos, which means it's the same as the sine of x plus y. Okay. Over, this is cos, sine, and we have a minus. So that is the cos of x plus y. But previously we said, okay, that's what we did actually from there, back here, from there, back there. All right, perfect. But we know that our sine over cos must give us the tan. Okay, identity of sine over cos, that must give us the tan of x plus y, which is equal to the right-hand side. All right, so that is how 6.1.2 would have been approached. Then 6.2, we are given f of x at the square root of that. Okay, they want us to solve for x in the interval 0 to 360 if f of x is 2. So what I'm going to do, let me jot it this side and say that f of x is the square root. Okay, that is the square root of 6 sine squared x plus 11 sine x plus 7. But they said f of x is 2. So I'm going to replace this with a 2. Okay, that is 6 sine squared x plus 11 sine x plus 7. Let's square both sides to get rid of the square root now. So I have a 4 is equal to 6 sine squared x plus 11 sine x plus 7. Move the 4 that side. Okay, which means I'm going to be left with a 3. So 6 sine squared x plus 11 sine x plus a 3 is equal to 0. Let me factor this out, or you can let sine x be a y or something, okay? So this can be 3 sine x. This can be a 2 sine x. How do I get a 3? It's 1 and 3. Let me call this a 3. Let me put here the 1. All of them are plus since it's just addition. All right. So if that is that, which means that my sine x here, if I equate this to 0, okay, I get 3 sine x plus 1 is equal to 0, which means the sine x is going to be negative a third. Or the sine x is going to be negative 3 over 2. Then I can use, remember, it is more like general solutions, okay? All I can do I need to use general solutions, really? Not really. Let me just find the reference angles, okay? So if the sign is negative, which means I'm dealing with quadrant 3 and then quadrant number 4. So what is the arc sign of 1 over 3? And that is giving me 19,47. That is my reference angle, okay? Then I know that in quadrant number 3, it's going to be 180 plus. Okay, so 180 plus 19,47, that's going to give me 199. Okay, 0.47. And then the other quadrant is quadrant number 4, where I'm having 360 minus 19,47. This must also give me 340,53 degrees. So these are the solutions that I'm getting there. When I look at this bracket, we don't have solutions in this case, okay, because our sign should never be smaller than -1 or bigger than +1. Okay, so that is this and that, okay? That's what the question needed. Then if you got the root of general solutions and then you substitute, you should be getting the same kind of thing. All right, then 6.3. Consider the function. Okay. Can we calculate the maximum value? So we know that maximum value relates more like to the amplitude. So the question is asking for the amplitude of this question. Okay, so what I have is sine squared of x. Okay, but we can't plot such graphs. So I know that sine squared can only relate to a cos 2x. So from the formula page, the cos 2x can be given as 1 minus 2 sine squared x. That is if I'm not mistaken. Let's go there and see. Okay, 1 minus 2 sine squared. Now, if that is true, okay, if that is true, which means that I need to make, or I need to bring in the cos 2x into the picture, where there is sine squared, so which means I need to move this one that side, okay, which is going to be 2 sine squared x is equal to 1 minus cos 2x. Then I can divide by 2 so that I have just sine squared x alone, okay? So where there is this, I'm going to replace it with all of that. Okay, so that's going to be 4 minus 8 into 1 minus cos 2x over 2. This whole thing is over 3. Then these 2 can reduce the 8. So by 2 is 1, by 2 I have a 4. Open up that. 4 minus 4. Then this negative from that, I'll have a positive 4 cos 2x. Everything is over 3. Then we know that this is going to cancel that. So which means it's just 4 cos 2x over 3. So this is our amplitude, and that is the maximum displacement of the graph about the rest positions. So which means that the maximum is 4 over 3. Okay, So that is how I would have gone about with that. That's the maximum value. Then 6.3. Write down the smallest possible value of x for which g will have a maximum value. So they're asking us, where do we find the graph to be maximum? What x value is it? So we know that the graph of cos 2x between 3, 6, and 0 should be something like that, round about that. Okay, so at this point, that's where we're getting our maximum of 4/3. Then at this point also, we shall have 4/3 as our maximum. But remember, they're asking for the smallest possible value of x. So at this point, x is a 0. This should be maybe 90. This should be probably 180. And so we need the smallest. So x is going to be 0 degrees. All right, so that is question number 6. Question 7, which is the tan graph. They're asking us that the diagram below the graph of f of x is equal to tan of x. It's given the interval between negative 180 and a positive 180. Can we write down the equation of the asymptote of f between 0 and 180? So asymptote is just that line where the graph does not touch. Okay, 7.1, we're going to say that x is equal to 90 degrees. 7.2, they want us to write down the values of x in the interval between negative 180 and 0. Okay, where the graph is below or equal to 0. So we can see that the graph is below from here up to this point within this interval. Okay, is below 0 or equal to 0. Then at this point here, the graph is just equal to 0 because it's still the same interval. So what I'm going to say is that x is negative 180 degrees, and then negative 90 is less x is less or equal to 0. That's my approach for 7.2. Okay, so we have this interval for this section here because this graph should never touch this asymptote. That's why there's no equal sign there. And then the fact that there is an equal sign equal to 0, it's equal to 0 at negative 180. All right, then 7.3. 7.3. If we are given g of x, which is 2x plus 1, g of x is 2x plus 1, can we write down the period? So this 2 will affect the period. So we know that a normal cos graph will have a period of 360. If we have anything extra there, we just have to divide. There's a 3 divided by 3. Now it's a 2 divided by 2, which means our period is going to be 180 degrees. Then 7.3.2, I'm just going to plot it there. Okay. On the grid in the answer book, they want us to draw this graph, okay, using the same interval. Must show the intercepts as well as the coordinates of turning points. So just follow the same criteria of how you plot your graphs with the calculator, okay? Mod, and then table, and then punch in everything, okay? So what I did, because these intervals of 99 are so big, I used 45 as my step, okay? So this helps me in quickly having a smooth graph thereof. Okay, so when I punch everything into the calculator, we say table, and then is it table that we're using? Yes, we're using the table. So mod table f of x, they told us it's cos 2x, then plus 1. So g of x we don't have. We're starting from negative 180. We're ending at positive 180. We said I'm using steps of 45. Okay, so negative 180, I'm having a positive 2. Okay, and then negative 135, I'm having a 1, which is there. 90 is 0. Negative that, I'm having a 1. 0, I'm having a 2. That, I'm having a 1. That's a 0. Then that's a 1. And then that's a 2. Somewhere there. And then all I have to do is connect this with my free hand. Okay, remember those are turning points, so they should be relatively smooth, not very sharp. Okay, so we have something like that. Okay, so that is g of x. That's what they wanted. And then 7.4, they want us to use the graphs to determine the general solution of this. So how many points is the graph meeting or the graphs meeting? So we're meeting at this point and then meeting at that point. General solution. Okay, so let's see. Step number 1, is it possible for us to express this entire thing in the form of cos 2x plus 1 as well as the tan x? That should be the first target. Okay, if we can do that, then we can get our answers. So step number 1, I'm going to divide both sides by okay, let me not divide. Let me isolate. So 2 cos cubed x is equal to the sine of x. Divide by just a cos, divide by a cos. So I'll have 2 cos squared x is equivalent to just a tan x. Okay, but we know from our formula page that cos 2x is given as 2 cos squared plus 1. Okay, now we only have 2 cos, this one. So let me move this one that side. Will that make sense? No, I think I made a mistake here. This is supposed to be minus 2 cos squared x minus 1. We can confirm that. 2 cos squared x minus 1. Perfect. Then if we move the one that side, it's going to give us the cos 2x plus 1 is equal to 2 cos squared x. So I'm replacing this whole thing by the cos 2x plus 1 is equal to the tan of x. Now we can see that f and g, they're equal, okay? So the point where f is equal to the point, or the point where f is equal to g, we see that it's between negative 180 and negative 90. So intervals of 45, this is equal. Then that is a 45, this is a negative 135. So I'm going to say that x must be positive 45, then x must be negative 135. All right, so that is question number 7. Question 8, which is the trig rules. Okay, in the diagram, sees the foot of vertical building. Then at top, same building, the height of the building, CD 16, okay. 2 observers are standing 19 meters apart at points A and B, where A, B, and C lie in the same horizontal or right. Painter is working at E, and so on and so forth. Okay. 8.1. They want us to get the length of AC, which is the distance between A and the foot, okay? So we can use this triangle, okay, CAD. From CAD, we have this angle. We're looking for this. So we have the opposite, we're looking for adjacent. We can use tan. So the tan of 46,85 is given as the opposite, which is 16, over the adjacent, which is AC, which means AC, if I cross multiply, is 16 over the tan of 46,85. When I punch that into the calculator, that is 16 over the tan of 46.85. That gives me 14,9987 which is, I'll take it as 15 units. Okay, so this is a 15. If we are to round it off decimals. Now, if that is a 15, 8.1 is answered. 8.2. 8.2. They want us to calculate how far the painter E is from the top. In other words, we need to find this distance here. So for me to get that distance, I need to find what CE is. For me to get CE, I can find this angle. Okay, let me start with that and say that BEC, and I'm going to use it somewhere. 180 minus that, there's that a 58 angles on a line. This is 7 max. Okay, that's 58. Then for me to get this, I'll need BC. For me to get BC, I'll need this angle here. For me to get this angle, I need this angle first. All right, guys, let me use the sine rule and say that from BCA, okay, if I'm going to use the sine rule, I'm going to say, I'm looking for a side, which is now BC over the sine of BAC should be equivalent to AB over the sine of BCA. Substitute BC is going to be AB, the sine of BAC, over the sine of BCA. So my AB is 19. I'm multiplying it by the sine of BAC. Aibo, what are you doing, bruh? BC, that's not going to make sense. Where are you going, my man? Where am I going? Where are you going? Because I know I have this, I don't know BAC. I cannot find those angles at the same time. Okay, so let's do this. Let's do this. I'm sorry for that. I'm gonna use the same triangle, but let me use AC. Now I'm gonna say the sine of CBA over AC should be equal to the sine of BCA over AB. Okay, which means the sine of CBA or ABC should be AC, the sine of BCA over AB. Okay, so my AC is a 15. We're saying the sine of 105,61 over AB, which is 19. Okay, for me to get my CBA, I'm gonna use the arc sine. Okay, shift sign of this entire thing. Let me punch this so that I see if we have the same answer. So that is 15. Sine of 105,61. Close that bracket over 19. Close that. So I'm getting 49,495, which is 49,5. Okay, so which means this angle here is a 49,5. Okay, then I can find this angle using the angles in the triangle. So BAC is going to be 180 minus this minus that. Let's do that. So 180 minus a 49,5 minus 105,61. That gives me 24,8. 24.89. 24.89 degrees. So if this is a 24.89, then I can use either the sine rule and find what BC is now. Okay. So I'll say BC over the sine of 24.89. It should give me the AB. Let me just substitute it. AB, which is 19 over the sine of 105.61. So BC over the sine of BAC is equal to AB over the sine of BCA. Okay, sine rule. Okay, let's make BC the subject, which means the BC is going to be 19, the sine of 24.89 over the sine of 105.61. Okay, 19, the sine of 24.89. Okay, we're dividing it by the sine of 105.61. That gives us 8.3 units or meters. It's meters. So if that is 8.3, then we can use this angle and then the tan. Is it tan? Yes, because this is now the adjacent. This is the opposite of 58. So I'll say the tan of 58 is equal to the opposite, which is 8.3 over EC. Let's look for EC alone. EC is going to be 8.3 over the tan of 58. Let's do that. That's tan of 58. That gives me 5.19. Now the distance that they want is ED. Is it ED? No. They want us to get the distance from the top to the paint. Yes, they want ED. So ED is going to be the 16 meters minus the 5.19. Okay, which gives me 10.81 meters. All right, yo. So this, then that, and 7 marks, it's worth it. All right, question number 9, okay? In the diagram, ABCD is a cyclic chord, beautiful. BC is produced to E, AC is drawn, A1 is a half of B, A2 is 46, and C1 is 86. 9.1, can we give reasons and find the value of A1? Okay, so we know that if this is 86, which means the whole of this must also be 86 because this is an exterior angle. This is the opposite interior. So I'm going to say that A1 plus a 46 must give us 86. Reason, exterior angle of a cyclic chord. Then let's move the 46 that side, which means A1 is a 40. All right. So if A1 is a 40, they want us to prove that AD, okay, this one is the same as DC. For us to prove that, we just need to make sure that C2 is a 40. That's the only thing we have to do. So what we're going to do, let's use this. So for us to get B is going to be twice A1, which means that our B is going to be 80 degrees. Okay, that is 80. And then angle D is going to be 100 reason. That is the opposite angles of a cyclic chord. Okay, so this is 100. If that's 100, that's 40, we can find C2, which means C2 is going to be 40 angles in a triangle, because 40, 100, and 40 must give us 180. Now you can say that since C2 is the same as A1, which is 40, therefore AD is the same as CD or DC. Reason would be the sides opposite equal angles, or the converse of angles opposite equal sides. So that is how we would have gone about with 9.2. All right, question 10. In the diagram, RS is drawn. Line AB intersects RS and RT at point A and B, respectively. Then AB is parallel to that. Okay. They want us to prove the theorem that states that a line drawn parallel with one side of a triangle must be proportional to the other two sides. In other words, we must prove that RA over AS is equal to that. So what we need to do here, it's just a construction. Let's go this side. We said it's just a construction. So in this construction, I can have this, and then I can have that. Let me also construct, maybe I'll call this my perpendicular, which is height 1. And then let me have another height this side. And then I call that height 2. Okay. So I'll start by using the areas and say that the area or ratios of area of RAB over the area of SAB. RAB, SAB. So that's going to be a half times RAB, I'm using H2, multiplied by AR or RA, over half times the same H2 multiplied by AS. You cancel the half on the H2, which means AR over AS or RA over AS. Then go down and look for the area of still RAB over the area of TAB. Okay, so this and then that. So that's going to be a half. We're using now H1. Okay, that's H1 multiplied by RB, that's our base. Then a half multiplied by the height, which is H1, and then BT or TB as our base. So that cancels that, which means RB over BT. But we know that the areas of RAB in both triangles are basically the same. So let's equate those ratios and say that therefore AR over AS should be the same as RB over BT. Okay, we said the ratios are equal and we have similar triangles, which means the ratio of RAB is in proportion to the bigger triangle. All right, guys, that is the hint of how that question should have been worked out. Then 10.2. In the diagram, O is the center of the circle. PWS is drawn with P. WS on the circle, OR is perpendicular to PS, is produced to T. SW and OT intersect at V. OV, okay, and OT. That's 4, which means that's a 3. Okay. Can we prove with reasons why the ratio of OR to WS is 1:2? Now, this question is, in other words, asking us to prove the midpoint theorem. For us to prove the midpoint theorem, we just need to make sure that this line is parallel to that one. That's the hint. We can prove that. The rest will be history. Okay. So what I'm going to do, I'm going to say that PSW is going to be 90 degrees. Reason, angle in a semicircle. Okay, so that is a 90. What does it make these two lines? It simply means that those two lines are going to be parallel. So I'm going to say, but PRO is also 90, which is equal to PSW. Therefore, OR is parallel to WS. Now, if these lines are parallel, okay, there's something extra we need to also add. Then we can see that O is the midpoint of PW, since O is the center of the circle. Then we know that from the midpoint theorem. Okay, what did that theorem tell us? That a line drawn parallel to one side of triangle divides the other two sides proportionally. Okay, in other words, if this is a midpoint, which means even this is going to be a midpoint. Okay, so we're saying that OR is parallel to that. Reason we said will be corresponding angles, or the converse of corresponding angles. Okay, if since then O is the midpoint, therefore R will be the midpoint. R is going to be the midpoint of which line? Of PS. Of PS. That is from the midpoint theorem, or from the proportionality theorem. Then we're saying that from the midpoint theorem, we know that OR must be a half. Why am I saying? Okay, OR must be a half of SW. When you divide both sides, then you're going to have OR over SW is equal to 1 over 2, which means OR to SW should be 1:2. Okay, so that is all they needed. Prove the 90 degrees here. Okay, give a reason. Then go on to conclude that these lines are parallel. Then bring in the midpoint aspect, and then use the midpoint theorem for the distance. Okay. Then 10.2.2, they want us to calculate the length PT. So we proved that this and that are parallel. They want the distance PT if ST is 15. Now we say this is the same as that. Just like that is the same as that. All right, so let's see. So if I use triangle, okay, I'm going to use TOR. Okay, so I'll have my RS over my RT. Let me call this. Okay, it should be equal to RS, which means it's OV over OT. Reason is going to be the proportionality theorem, because OR is parallel to WS. Let's do the substitution. So X over X plus 15 should give us the ratio of OV to OT, which is 1 over 4. Cross multiply. 4X is going to be X plus 15. Move the X that side. 3X is a 15, which means X is a 5. So then if this is a 5, okay, we said, but PR is equal to RS, which is equal to 5. Then PT is going to be 5 plus 5 plus 15, which gives me 25 units. So that is how the 4 marks would be obtained. So that is 10.2.2. Question 11. Question 11. In the diagram, A, B, G, F lie on a larger circle. A smaller circle is drawn to touch the larger circle internally at A. A is common tangent to both circles. That's a tangent, the smaller circle that is produced, and all of that, they are drawn. Can we determine with reasons for other angles? Sweet 6 marks. Let's see. So EAG, in other words, the whole of this is X. So for other angles, so since this is a tangent, which means the whole of this must also be X. Okay, so I'll say AFG is equal to X. That is the tan code. Okay. Then the other one I'll see is that D1 is also X. Since that is X, this must also be X. D1 is X. That is also a turn code. Then if this is X, which means this C1 is also going to be X. We can also use turn code. Or since this is a tangent, that's also a tangent, we can use tangents from a common point. Okay, turn code or tangents from a common point, one of the two. Then the third angle is going to be C4, this angle here, because this and this will be vertically opposite angles. All right, so we have our 4 angles as per the question required. Okay, so we say that is X, 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 and U are also X. Even this one, X. Okay. Then can we prove that AG times AD is equal to that and that and that and that? So what we need to know is that since D1 is X, okay, let me put it here. That says that since D1 is X, which is the same as AFG, simply means that these two lines are going to be parallel. So CD will be parallel to GF. That will be the converse of the corresponding angles. And if that is true, then we can see that this small triangle is similar to the bigger triangle. Okay, so therefore, we're saying that ACD is similar to AGF. Then let me compare the sides. So I'm going to say AG over AC is equal to AF over AD, and then just cross multiply. So that's going to be AG times AD should give me AF times AC. So that is what the question wanted in 11.2. Then 11.3, they want us to prove that some triangles are similar, okay? AGF, the Makulu triangle, okay, this big triangle, that it is similar to ABC. Let me use this. All right, so what I can spot from the word go is I have this X here, and then I already have the X there. So what I'm going to say, I'll say that AFG is the same as ACB, which is X. We've proved that, okay? Because initially they told us to show that that's okay. So that is proved or proven. Then if that is true, we can also see that G and B2, because of the bow tie, okay, we can see this bow tie here. So G is the same as B2, that is angles in the same segment or angles subtended by the same chord AF. Then lastly, we know that A2 is going to be the same as A3. That's going to be the remaining angle of the triangle, or the third angle of a triangle. Now we have the prefix, therefore, our AGF is similar to ABC because of angle, angle, and angle. So that is how we will have obtained the formats. Then lastly, 11.4, they want us to prove that GF squared is given as that. So my first approach is to compare the two triangles, okay? So what I'll do is just sketch the two triangles here. Just, okay? So I have A, this is B, this is C, this is A, this is F, this is G. That is X, that is the dotted that I had. This is the A2 and A3. All right, then let me compare the sides. So if I get the AB, should I start from there? Yeah, I'll say AB or AG. Let me start with the big one. So AG over AB should give me BC over GF, which must also be the same as AC over AF. I mean, those sides are in proportion because these two triangles are similar. But my point of interest is these two triangles. You see, triangle ABC is also similar to triangle, this one, because they are, okay, if they are similar, why are they similar? Because this and that, okay? And then this angle here, and then this angle here as well. Then this one, and then that one, vertically opposite. So they are similar. So which means that if I consider that, I'll have my AC. Okay, where's the AC? This is AC over the FC. Okay, so I'll have, okay, from triangle ABC, which is similar to triangle FCG. So I'm having AC over FG. Sorry, FC is equal to AB over FG. I can make AC the subject at this level. And then I'll have AB times FC over FG. I can call this my equation number 1, okay, or just the starting step. Then 11.2, we had this. Let's also generate something from this. So from here, let me make AC the subject, which means it's going to be AG multiplied by AD over AF. Then I'm going to equate the two, okay, because it's AC and AC. So I have AG times AD over AF is equal to AB multiplied by FC over FG. Okay. So what I can see, I need to bring out something weird. And that's something that I need will be the AG over AB. I need this come out of this. So AG, so it means I need to take this one that side and bring this one down. So I have AG over AB. If I bring this one down, I'll have my AF multiplied by FC over FG multiplied by AD. Okay, we're not yet there, we're almost. Call that probably equation number 2. And then lastly, we're saying, but we know that AG over AB is going to be the same as FG over BC. Saying AB, no, it's AG. Okay, this whole big side over AB should be the same as FG over BC. So which means I'm going to replace this with that. So that I have my FG over BC is equal to AF times FC over FG times AD. Then multiply this that side and multiply the other side. So I'll have my FG squared, because if I get, let's say, times FG on either sides, okay, times FG times FG. So this cancels that. And then I multiply both sides by BC times BC, and then times BC. This cancels that. So I'll have my AF, my FC, and then my BC over the AD, which is down there. Isn't that what the question wanted? BC, we have it. FC, we have it. AF, we have it over AD. So that is how those 6 marks would also have been claimed. All right, guys, we've come to the end of the question paper, of paper 2. And on average, we can say this paper was fair enough compared to other paper 2s that we've seen in the previous years, okay? It was fair enough. Remember, this is just the proposed memorandum. It's not the exact one, okay? So if there are any issues where we're not getting along, feel free to slot that under the comment section and we shall rectify that further, okay? Thank you very much. And then all the best in your remaining examinations. Bye-bye.